Hello all, myself Mrs.Manasi Hande, Assistant Professor in the Department of Information Technology from Changu Kana Thakur Arts, Commerce and Science College, New Panvel. Today we are going to discuss an important concept in DBMS called keys in DBMS. Keys play a very important role in relational databases because they help us identify records uniquely, maintain data integrity, and establish relationships between different tables. In this lecture, we will understand what keys are, why they are important, and then we will discuss different types of keys in the DBMS. Let us start with the definition of keys. In a relational database, a key is a field or a set of fields in a table that uniquely identifies each record. Whenever we store data in a table, there may be many rows. A key helps us identify exactly one row among many records. Keys are fundamental elements of a relational database models because they ensure uniqueness, maintains data integrity, and help in efficient data access. They also help in creating relationships between different tables in database. Now let us understand why keys are so important in DBMS. The first reason is uniqueness. Keys make sure that every record in a table is unique and can be identified individually. The second reason is data integrity. Keys help prevent data duplication and maintain the consistency of the data. The third reason is efficient data retrieval. Keys help in organizing data properly and allow faster searching and querying of the records. Because of these reasons, keys are an essential part of DBMS design. In database systems, there are different types of keys used for different purposes. Some commonly used keys include primary key, super key, candidate key, unique key, foreign key, alternate key, composite key, surrogate key. Now let us discuss each of these keys one by one. Primary key. Let us begin with the primary key, which is the most important key in a table. A primary key is used to uniquely identify each record in a table. There are two important rules for primary key. First, it cannot contain duplicate values, and second, it cannot contain null values. Every record must have a valid identifier. A primary key can consist of a single column or multiple columns. For example, in a student table, the student ID or student number can act as a primary key because it uniquely identifies each student. Next is a super key. A super key is a set of one or more attributes that can uniquely identify a record in a table. Sometimes super key include extra attributes that are not required for uniqueness, but in the combination still uniquely identifies the record. For example, if student number uniquely identifies a student, then combinations like student number and name or student number and phone will also uniquely identify the student. These combinations are called super keys, although they may contain unnecessary attributes. Next is a candidate key. A candidate key is a minimal super key, which means it uniquely identifies records without containing any unnecessary attributes. A table may have multiple candidate keys, but only one of them is selected as a primary key. For example, in a student table, both student number and phone number may uniquely identify records, but both are candidate keys, but only one will be chosen as a primary key. Next is unique key. A unique key is used to ensure that all values in a column or a group of columns are unique. It is very similar to a primary key, but there is one difference. Unlike primary key, unique key can allow null values. although duplicate values are not allowed. Unique keys are often used for attributes such as email IDs, usernames, or phone numbers where uniqueness is required. Now let us discuss a foreign key, which is very important for maintaining relationships between tables. A foreign key is a column in one table that refers to the primary key of another table. This helps connect different tables in a relational database. For example, suppose we have two tables, student table and a course table. The student ID in the course table may refer to the student ID in a student table. In this case, student ID in the course table becomes a foreign key. Foreign key helps maintain referential integrity between related tables. Next is an alternate key. An alternate key is simply a candidate key that was not selected as a primary key. When multiple candidates keys exist, only one is chosen as a primary key. The remaining candidate keys become alternate keys. For example, if both student number and phone number uniquely identify records, and student number is selected as a primary key, then phone number becomes the alternate key. Next is a composite key. Sometimes a single attribute is not sufficient to uniquely identify a record. In such situations, we combine two or more attributes to form a composite key. A composite key is therefore a key formed by combining multiple columns together. For example, in a student course table, a student may enroll in a multiple courses. In that case, the combination of student number and course number together uniquely identifies each record. Hence, this combination forms a composite key. Here is the example. Next, we have a surrogate key. A surrogate key is an artificial or system generated key used to uniquely identify records. Unlike natural keys, surrogate keys do not have any business meaning. They are mainly used to simplify database design and improve the performance. Example includes auto-incremented IDs generated by the database systems. To summarize this lecture, we discussed the concept of keys in DBMS, their importance in maintaining uniqueness and data integrity, and different types of keys such as primary key, super key, candidate key, unique key, foreign key, alternate key, composite key, surrogate key. Understanding these keys is essential for designing efficient relational databases and managing data effectively. Thank you.